Okay. Hey, I'm Vinod. I'm here to present on Hadoop Yarn, present and future. I'm a member of the Hadoop Project Management Committee and one of the first few people who started the Yarn project, and I'm now at Hortonworks. So before I start my presentation, thanks to all of you for attending this presentation. I know we're all spoiled for choice, and you're making a trade-off by coming to this presentation. I'll try to make it worth your while. Next, I would like to give a quick shout out to two entities. Apache. Without Apache, we would not be here. The big data ecosystem project is, the whole ecosystem is where it is partly because of Apache. Secondly, what a day, to also give a shout out to Yahoo for some of the pioneering work that they've done, 10 years ago. A very quick introduction about me. I was originally part of the Yahoo Hadoop team, which was running, Hadoop before the rest of the world knew about it. And then when Hortonworks happened, I moved over. So this is the funny thing. Last year, we celebrated 10 years of Hadoop. And this year, I am celebrating my 10 years involvement with Hadoop, a great milestone. And this is one piece I keep repeating every year. Finally, you can start looking at job profiles which talk about 10 years of Hadoop experience. Yeah. So I guess my biggest contribution to Hadoop is originally Hadoop was a MapReduce-only paradigm. I helped rewrite that to be a more general-purpose platform, which is now called Yarn. And I'm right now running compute platform teams at Hortonworks. It includes Yarn, MapReduce, Slider, and a container cloud in Yarn. So this is a short and brief agenda. I'll quickly introduce, for those of you who are new to the space, I've seen that every year there is that 10% of people who are completely new to the ecosystem, which is good, right? So I'll quickly repeat why we are doing what we're doing, and then dive into the past, present, and future. So how does Hadoop Compute Platform look today and tomorrow, right? So the overall goal of Hadoop Compute Platform is really about data, right? If there were no big data, there was no Yarn. And how we facilitate big data is by implementing and supporting these layers that enable applications and higher order frameworks that do all sorts of different things with data. And Yarn is the core of that applications and frameworks. It's multicolored. What I mean by that is, for a big part of its history, Yarn was only good at supporting short-running jobs and applications that, at worst, can run for 7 days. Right now, we are in a phase where we can now support truly long-running services. So that's what makes it multicolored. And to complete the picture, you have a data lake. You have Yarn to manage applications and services. You also have administration tools like Ambari, which help users' insights manage and monitor their clusters. To, again, help the 10% of the people who are new to this, why we are doing what we're doing. The core of the problem is, you have this data lake where you have data and different actors are coming in and interacting with that data in a wide variety of forms. And there are different actors here, right? On one side, you have users. On the other side, you have cluster administrators. And the asks from these different types of actors on things like isolation, capacity allocation, and scheduling, they happen to be completely polarized. On one side, we have users. One set of users could say, give me SLAs. I want my query to be finished in so-and-so time. A different set of users could come in and say, I want my query to run faster. It was running extremely slow. Somebody else could say, hey, I know there are a whole bunch of tools that are already in the ecosystem. I want more. There's a new project that I attended on a talk about. I want that framework to run inside this cluster so I can interact with my data in new ways. There are yet more set of people who want everything right now, right? So that's the dichotomy, right? And you have other users who combine all of these different dimensions. So this is from the end users, right? The end users are selfish. They are only looking at their own, worldview, where I want my query to be fast right now, and so on. On the flip side, the cluster administrators are looking at the usage across the board. They're looking at all these workloads run by users, and they want to make sure the cluster has the highest throughput possible, highest utilization. They don't want any resources to be wasted, so they want to enable elastic sharing of resources. They want to make sure the service is up and running all the time, and his or her users are not affected. And bottom line, why are we doing all of this? We want to make sure that there is a business value for these big data workloads, right? So that onus is also, it usually ends up on the cluster administrators to demonstrate value and return of investment. So this is a challenging problem, right? There are a different set of actors asking for different things, and left alone, and there are, you can totally see some organizations where this dichotomy doesn't exist. The end user is also the DevOps, and he's also the operator, and they happen to be smallish clusters. That's not a place where Yarn shines. The place where Yarn shines is you have a reasonably large group of people in an organization come together, interact with shared data, run workloads in a multi-tenant cluster, and you're trying to do all of these things. So with that, the way I want to paint a picture on how the platform looks today and tomorrow. So you have a bunch of platform services. We talked about storage and resource management. These are the foundational blocks on which everything else is built. You have management, monitoring, and alerts. Once this cluster is up and running, and it's running on hundreds of thousands of nodes, you want to make sure you can service it, you can monitor it, and so on. So this is how we originally started. This was the thinnest possible platform service we had. And then we started running MapReduce workloads, right? And then MapReduce had a bunch of issues. It was very successful at what it does. The next evolution was a framework called Tez, and Hive and Pig, and things like that. Tools that are on top of MapReduce and Tez, they all ended up running on Yarn. Then Spark happened. Then, recently we announced the notion of Hive running on an LLAP platform, and LLAP also is running on Yarn. And the hits kept on coming. You have Flint, you have Flink, apologies. So as we started adding more and more of these, the platform, we realized there are more things that we have to add to the platform. So some of the new layers that we are adding now are the notion of a service discovery, so that once all these different apps are running in a dynamic multi-tenant environment, how do they find each other? The next evolution of that, this is something that I've talked last year, is a notion of an assembly where you're no longer dealing with tools like Hive and Tez and Spark and Reef. Instead, you're focusing on end-to-end use cases where you have an IoT app that is interacting with Kafka and Storm and HBase and Solar. You want to put all of them together, thank you, and run it in a multi-tenant platform, right? So that's how the picture looks today and tomorrow. Now, I would like to quickly go through past of Yarn. As you might know, Yarn is a sub-project of Hadoop. So our story is tied to Hadoop releases. And this is way back. So I'm talking about 2010 when we wrote the first line of code. And we went, we open sourced back when we were in Yahoo, Yarn into Hadoop in August 2011. So I'm really going back farther in time. So this is a bunch of GA releases. The reason why I have put all of this is I want to show how things have evolved over time, right? 2.2 was the first open GA that was available to our users. It had a whole bunch of things. And the pattern that I wanted to impress upon you guys is every year there are 3 to 4 releases of Hadoop, focusing on different features and stabilization. So, and the recent history is all of 2016 and beginning of 2017, we have 2 different tracks. The branch 2 line is focused on stabilizing what we already shipped in that timeline. And we have now a spate of 3.0 releases that are surfacing some of the alpha stuff in the branch 3 line. So in the near future, this is how you look at it. There are 2 release lines, branch 2 and branch 3, right? So quickly moving to present and future. So before I jump in again, I am representing the entire Hadoop Yarn community. So all of this is not my code. I'm representing a whole bunch of people who have spent their time, either writing code or testing stuff. So look at it from that filter. So I try to quickly categorize the different type of initiatives that are happening right now in the Yarn community. The pace is breathtaking, and it's happening at all layers. At the lowest layer, you have support for containers and resources like GPUs and FPGAs. Yarn has always had support for memory and CPU. Now we're moving into additional resources. I'll talk about some of this briefly. The Next level of initiatives are in scheduling. We want to do much more powerful scheduling. We want to do schedules much faster. What this really means is, again, going back to the picture that I painted before, different users are coming in and they have different requirements. Somebody wants very fast response time. Somebody wants throughput, right? Trying to balance all these different asks is something that Jan was already involved in. We are now taking it to the next level. I'll briefly talk about what this entails. So that's on the lowest level and the scheduler. On top of that, there are initiatives in the community to take Yarn to the next level of scale and SLAs. On top of all these building blocks, you have service workloads, usability as the some of the new initiatives. So that's the theme. I'll split that into what's happening in the 2.8 release line and what's happening in the 3.0 release line. So in 2.8, so I'm focusing on the scheduling features now. We have a notion of application priorities within a queue. So before this feature, the picture looked like this, right? Apps come into a queue, they run one after another, and whether you're running a capacity policy or fairness policy, they get resources, right? Specifically looking at FIFO policy, the way it gets changed once you have priorities in is app 1 came into the cluster first, but it happens to be one of the lower priority jobs. The app 2 comes in with higher priority, so it starts getting resources first, and so on, right? The good thing is each of these policies are very pluggable. So you could say QA has FIFO, QB has fairness, and QC has priorities. You can mix and match because, again, different organizations, different subgroups will have different expectations of how their workloads get scheduled. The next feature is the notion of a queue priorities. Today, without this feature, the scheduler always gives resources to the least satisfied queue. So a quick example here is there are two queues. The first one has 20% configured capacity. The second one has 80%. But in terms of real usage, first queue is only using 5%, which will put its usage to be 25%, right? The second queue, even though it has a much larger headroom of going up to 80%, its current usage is only 10%. The scheduler looks at it today and basically says, hey, the one on the right is using less, so let me give that resources. Even though in many cases you want to actually give that capacity to Q1, and the way you affect that is by setting priorities. You say that the queue on the left or your left is a higher priority queue, so irrespective of its demand, irrespective of its current usage, that queue gets resources. Next one is the notion of preemption within a queue. Now we have decided that we are running it in a shared cluster, and two users are sharing the resources in a cluster, and a bunch of different dynamics happen here, right? User A comes in, he sees that the entire cluster is free, he goes occupies all of it, and now the user B comes in and he says, hey, I was promised 60% of the capacity, but now the other guy is running. How do I get my capacity back? Today, Yarn facilitates that sharing by the notion of preemption, which really means killing containers of the first user, right? So before this feature, preemption was only restricted to across queues. This now takes it to the next level, which is within a specific queue, you have different apps of priorities and different users. They get sharing, they get their fair share much faster. Without this, they would have to wait till the other workloads finish. The final bit in scheduling is the per queue policy-driven scheduling. I kind of briefly hinted at it before. Before this feature, there was one global policy in the entire cluster. Everything is first in, first out, or everything is fairness. Now you can mix and match. You could say, the ingestion queue is first in, first out because I'm focusing on throughput. The ad hoc queue where users are coming in and running queries, I want to give fairness. You can now mix and match each of these policies at a queue level. So the different dimension to scheduling is, the way things work till now is you submit an application to the queue, and depending on the policy, it gets resources. Microsoft has been working on this feature called reservation for a year or so, wherein you could say, I know that my workload is very predictable. The resource usage looks something like that in terms of a skyline, but I don't want to submit the application right now. I want to run it at tomorrow 6 a.m. So with reservations, you could go to Yarn and say, hey, this is my skyline. I want you to make sure I get these resources when I come into the queue at 6 a.m. And that leads to different dimensions of additional use cases like, hey, I have these two reservations which are dependent on each other. So some of this work is available, has been available for a year. The new stuff that's happening here is you can now put, the reservations are persisted, so even if the cluster goes through restart, the reservations will be served. The second bit is you can actually now start giving recurrent reservations. It's not just run this workload at 6 a.m. tomorrow, run it every day at 6 a.m. and run it for 3 hours, right? So throughout this presentation, I'll point you to a few other talks that will deep dive into these topics. There's no way I can do a justice of all the innovation that's happening in the community. So please go attend this talk by Subru and Carlo from Microsoft, where they deep dive into how they do it and all sorts of different combinations. So that's 2.8. And 2.8.0 was a release that that's already out there. It's in alpha stage right now. We are going through a bunch of downstream testing and user acceptance. So 3.x is a series of alphas. Again, 3.x itself is a massive initiative. Community of developers have been working on this for a while. Please go attend this talk on Hadoop 3 by Junping from Hortonworks and Andrew Wang from Cloudera. This is a fun talk. We're actually at a place where I'm seeing similar stories about migration from 1.0 to 2.0. From the community perspective, we are trying to make it as seamless as possible in terms of compatibility, upgrades, and so on. But there are minor issues, so please go attend this talk to get a deeper understanding of what's happening in 3.0. So from Yarn perspective, one of the big things that's happening is scale. For those of you who have listened to the keynote in the morning today, the last few years, the largest Hadoop clusters, largest Yarn clusters have been in the 6K, 8K, 10K range. Close to a year ago, Microsoft came with this roadmap of saying, let's scale Yarn to infinity. More concretely, 100,000 nodes, right? And they have already made a whole bunch of progress on this. They have a talk where they're basically saying they've learned a whole bunch of lessons running Yarn at 40,000 nodes. So this should be a very interesting talk for those of you who incline towards scale. Moving on, so scale is one piece. On the scheduling side, there are two efforts that are led by Wang. The problems that we are solving are, today the scheduling is done a node at a time, and let's say in 5 seconds, 1,000 nodes can come in and talk to the scheduler and say, give me work, right? That was okay for the kind of workloads that we've always been running, like MapReduce, Hive queries, and Spark, and so on. But there are a whole bunch of new workloads that need much faster scheduling than that. So trying to look at one node at a time is not going to cut it. A, in terms of speed, B, in terms of optimal decisions, right? Because the scheduling is based on a node at a time. You might actually be better off waiting for a little while and find the right machine instead of giving tasks to the specific node that is turned in. There is also a bunch of coarse-grained locks in the scheduler. So fixing these, we've got an awesome number here. We can now allocate up to 3,000 containers per second. So this is one of the biggest design goals of Yarn 2. We want to do a lot of scheduling decisions in a very short time, specifically when it comes to tasks and queries. So that's on the number of containers we can create. It leads to about 10x throughput gains. There's one minor feature. People have talked about the limitations of the capacity scheduler percentage model. There are big trade-offs here. We've seen a bunch of users trying to manage their clusters in terms of absolute resources instead of percentages. So in the current world, you would say sales, engineering, and default, they're all running in the same cluster, and they've funded this cluster. So in that fashion, so I'm going to give 30% to sales, 65% in engineering, and even in engineering, I want to split the resource usage by so and so. So with absolute numbers, that translates to 30 gigs, 65 gigs, and so on. So this way, you can have tighter control in terms of absolute numbers, but the downside is the percentages are good when the cluster grows and shrinks in size, right? So even if you suddenly gain 50 nodes or you lost 10 nodes, the percentage will automatically shrink up and down. That's an issue with absolute numbers, but it has its own pros. Moving on to the lower levels, Yarn, like I said, always had a support for memory and CPU. Now we are extending that to a more generalized vector. The first concrete example of that we're chasing is GPUs. So the administrators can say this node has 2 to 6 GB RAM and 64 cores. And by the way, there are 4 GPU devices, each having so many cores, right? So that's one piece of it. So that when a new resource, when hardware vendors push for more extreme hardware, we can actually support those resources in Yarn without additional code changes. That's one dimension to it. The second dimension is how do you support each of these devices themselves? Like let's take GPUs as an example, right? Why do you want to run GPUs in a Yarn cluster? I have memory, I have CPU, all the big data workloads are using them in Yarn cluster. I have all this elastic sharing, queue capacities, et cetera, et cetera. But now there is the machine learning group or the deep learning group. There's a small team of 5 engineers right now who want GPUs. So let me buy them and give them their own cluster. That's how it starts, and that's how everything starts. And then that project achieves some success, you get 10 more machines and 10 more machines, and you keep adding users, and you come back to the same problem that I highlighted in the beginning of the presentation. I have resources, I have expensive resources, how do I share them? How do I make sure they're utilized well? How do I get a good return of investment? That's the reason why you would want GPUs on Yarn. I'm not deep diving into why GPUs. Specifically on supporting GPUs on Yarn, there are different levels of support too. It's not like GPU support is new in Yarn. We have had a notion of a node labels where it's very coarse-grained. What it'll do is Yarn understands that a specific set of machines have GPUs and others haven't. It'll simply try to take you to that machine, right? But that's not enough because, so I'm walking through these 4 scenarios. The first scenario is the user comes in and says, give me a full GPU device only to me. I don't want to share it with anyone. And give it to me for the lifetime of my container, whether it runs for a day or a week. Give that entire GPU to me, even though I'm only going to use the GPU for a small bit of the computation, which probably finishes in an hour, right? So that's use case 1. Use case 2 is user comes in and says, for the entire lifetime of my container, give me multiple GPUs. There are 4 devices on this machine. Give them to me. Moving on to the complexity chain, to solve this underutilization of GPUs, users could come in and say, give me these GPUs, but I only want it for an hour. For the rest of the application, I want to give this back to Yarn, right? The final one is the hardest one, which is I don't want a full GPU because a GPU itself has thousands of cores, and my application only needs a small small bit of that. So just like we do CPU slicing, you can imagine GPU slices should also be distributed to the users, right? So it's a complex problem. Scheduling GPUs is one piece. That's what I talked about in the generalized resource vector. But supporting GPUs as a first-class notion, with all these use cases in mind, it's a big initiative. Putting this all together, there's a talk where Wangda and Yanbo from Hortonworks, they're looking at machine learning workloads with TensorFlow and how you can run all of that on Yarn and GPUs. So that should be an interesting talk for those of you looking at deep learning. So I guess I messed up the layout a bit. So there's also one more thing called placement strategy. Remember I talked about how Yarn always supported queries. And one of the big deals of Hadoop is data locality, right? With changing hardware trends, it may or may not make sense in your cluster. But that's been one of the core features in Yarn. Now with services and other types of applications running on Yarn, you have requirements, fancy requirements like affinity and anti-affinity. Like one example is, HBase is already running on Yarn in some set of machines. Now I want a stream processing application and try to put it as close to the data as possible, right? It's not data locality in the historical sense that we used in MapReduce, but it's more, even if the underlying HBase cluster moves around, faults happen, I want you to make sure that my stream processing application always sits close to the data, right? So that's an example of affinity. This is a big initiative that's happening in the community. So I'll switch gears to another umbrella item, which is services on Yarn. There are a whole bunch of different initiatives happening in this area. The first one is Docker. So containers, Yarn always had a notion of a container, but that container is more of a process tree on Linux. Docker has made the LXC accessible and popularized. It can replace VMs in some cases because people have started using VMs in places where they didn't need to. And to support this, Yarn has native integration of Docker apps in Yarn. This is a work in progress. The way we enable it is by the notion of container runtimes. So some of you may ask, why are you doing this in Yarn? Why can't I bring my own Docker platform separately, right? Similar to what I talked about before with GPUs, if your big data app is, a lot of it is running on high event Spark in the big data cluster, and I have these two containers which want to either consume the output of your big data pipeline. Today, you'll have to copy this data from your data lake, put it outside, run your containerized app in a different platform. What this is really going to facilitate is you run all of this as a pipeline in a single platform, and the extra containerized apps that you have, you run it in the same platform. You get the same good of Yarn scheduling, queuing, elastic sharing, etc. But you can mix and match container runtimes. You have the process runtime, which runs your Spark high workloads, but you can also now run Docker containers. Second piece is how do you simplify APIs, right? So what is Yarn's API? None of you actually deal with the Yarn's API because frameworks like Spark and Thais and MapReduce, they'd interact with Yarn, right? So that works okay for big data apps, and each of them have some philosophy of how you should write your application, right? The second set of workloads that we're bringing is you have an existing application, like think Kafka, think HBase, think Storm. These are services that you're already running. Today, for whatever reason, you're running in a siloed cluster on a small set of machines. You want to bring that on top of Yarn. We want to make that experience extremely easy, right? So one example I have here is remember that big data example I gave? I have done my entire pipeline. The output is a very small set of data that I want to, say, serve through an Nginx app. You can simply say, I have this Nginx Docker image. I want you to run one container of this, and I want you to run it only for an hour, because after that, it's supposed to go away. By writing a simple spec file like this, you can actually run this Nginx containerized app on top of Yarn in a matter of seconds, right? So most of this code is in a branch based off trunk. We are working on merging that to trunk. The next piece is, sure, I'm already running this Spark, HBase, and Nginx app on Yarn. I realize I have to upgrade this app. And there are two ways to upgrade it. With traditional apps like MapReduce and Spark, you would actually say, the next instance that I'm going to bring up, it'll pick up the latest bits. That's okay for apps, but it's not okay for services. Because if I have an HBase running on Yarn, you want to make sure the users of that service are not impacted. You want an in-place upgrade, right? So Yarn 4726, this is being worked on by Arun from Microsoft and Jian from Hotworks. You can actually say, I'm running this app, do a rolling upgrade of this app on Yarn without actually impacting the end users. The next piece is you have all these services running on Yarn. You want to be able to discover each other. We have a notion of a service registry that we had for a while. Now we have married that with the most popular service discovery of all, the DNS. So you can actually say, in my configuration, in my stream processing application, I want to talk to region server 30.hbaseapp.myuser.yarn.site. What this will make sure is, irrespective of where this region server is running, you can always talk to it using DNS. To close it all, we have also looked at Slider as a framework. Now it's been merged into Hadoop Yarn as a native Yarn services framework. And Slider is what actually orchestrates your application. Start the HBase master first. After it is up and running, go and start region servers 10 at a time. So that's a native services framework. Again, this is in a branch. We are working on getting it into trunk. So putting it all together, those of you who have attended last year's summit, you might have seen that some of this work got started at that time. We have taken it all together, and I'm happy to report that we've been running some of this stuff internally inside Hortonworks. And there's a talk about how we run a container cloud and Yarn. This is done by Shane and Jian from Hortonworks. If you're into a thing like this, please attend this. To conclude, there's a bunch of user experience initiatives. We have revamped the new Yarn web UI. We also have Hortonworks and LinkedIn working together on this notion of API-based queue management. Today, you have to go and manually edit files and send refresh commands to scheduler. Instead, your tools can make REST API calls and say, go add this queue, go delete this queue, change the capacity of this queue, right? That's one. The second piece is it enables decentralized queue management. Today, if you want to increase the share of your queue resources, you have to go talk to the cluster admin and take his blessing, and then he will actually talk to a whole bunch of stakeholders, convince them that, hey, this queue can now go from 30 to 31%, right? That's something you don't actually want to be blocked on a central entity. And many of your users have actually expressed interest that, hey, I want to manage it at my level, but any changes further down in the tree, I want it to be decentralized. And LinkedIn has actually installed this in their cluster, and I think they've been running it for close to 6 to 9 months. So we are working with them to now bring this to the community. So that should help ease operations. And finally, there is a whole bunch of improvements on how we do logs with Yarn. Again, there are twists to here. When you run apps, you want logs available in some fashion. When you run services, you want it in a different fashion. So there is ongoing work in this area. The final mega initiative that's happening is timeline service. Users and cluster owners of our platform, they have all these questions. Where did my containers run? So from an application point of view, they ask questions like, where did my containers run? Why is my application slow? Is it really slow? Many times I've seen cluster operators complaining, hey, this user is coming to me and telling me that this query is essentially is suddenly slow. I go back into his history and see that it has always been slow. It's just that he woke up recently. But till now, we never had tooling to actually prove that is indeed the case. Right? On the cluster point of view, the admins want to figure out who is the user who is using the most amount of resources, what is the largest application, is there something wrong with my cluster, why is everything slow all of a sudden, right? You get the idea, right? There are a whole bunch of questions that people want to answer from apps point of view and from clusters point of view. And timeline service is a massive initiative led by Twitter, folks from Twitter, and contributors from Hortonworks, Cloudera, a whole bunch of things. It's a mega initiative that is being worked on to answer these questions. Some of this is already there in Trunk and 3.0 releases. The goal, if you want to summarize in a single line, is analyzing what's happening in a Hadoop cluster has itself become a big data problem. So we want to leverage things like HBase that we have already told our users to solve their big data problems, right? So that kind of wraps up all the features that we have. If you want to see all of this together, there's one session by Edgar from UC Berkeley, and he's interned with Hortonworks. He builds a modern data application and puts it all together, so that you might want to go check that out. That concludes my session. I wanted to spend 30 minutes and pause there. So I'm open to questions. We have 15 minutes, I think. No questions? Then we all get, okay, there's one there. I'm sure you have questions. That's a lot of innovation from community. It took me a while to actually try to summarize it.
Okay.
Yeah, okay. I'll take this, I'll repeat the question from here, and then yeah, go ahead.
For the scheduling, you said each queue itself has FIFO and priority. Is that available with 2.72 or 2.73?
Okay, so the question is, each queue, being able to configure each queue to have a different policy, whether it's FIFO or fairness or priority. So that's there in 2.8 alpha releases right now.
2.8?
Yeah. Yeah. Yeah, unfortunately, the answer to most of your questions is wait for 2.8 and 3.0, and that would mean upgrading your clusters. I understand that's a pain. But we also, at the same time, didn't want to destabilize releases like 2.6 and 2.7, where a lot of production workloads are running. So most of the new feature work is in some of the late alpha releases. Yeah, go ahead.
Can you give more details on the Yarn log management? Is that the same as timeline service with different?
So the question is the log management same as timeline service? No. So we actually don't want to put logs in HBase. HBase is more like metadata and the application and cluster level metadata. Logs right now we are pumping into HDFS. And there have been asks to make this pluggable so that people can send their logs to their own favorite logging system. So the specific enhancements that I talked about are more in terms of the tooling which exposes logs from running applications and running containers. Yeah, that's not the same as timeline service. Yeah, we don't want to actually put logs in HBase. I'm sure Const has answers to some of why. Yeah. Okay, whole bunch of questions here. That's good.
What kind of metrics are being used in application history server that you showed and answer questions like why applications is slow and which user is making it slow? So what metrics are used there to answer those questions?
Right. So one of the reasons why the whole timeline service project has become a complex beast is each question needs a different type of metric, right? Is the cluster slow? The kind of data that you need to answer that question is actually different from why my application is slow. And maybe some of them are related, right? So it's actually, the answer is it's using a wide variety of metrics. Every app sends what it sees. The platform also sends information on what it sees. Like resource manager says, I'm seeing that there are so many app failures. Node manager says, I'm finishing so many containers, right? Our goal is to put all of this data from these disparate parties in one place and answer those questions. And we understand it's a challenging problem. It's a data science problem in itself, right? How do I take this data, merge it with this, and then answer a question? So yeah, it's a diverse set of metrics. There's one question here, and then we can come here. Okay, he has the mic. He won. He's got the priority.
Is Yarn moving toward fine-grained control over memory and network? And if so, I mean, do you see it as eventually competing with like Kubernetes or Mesos?
Yeah. So I'm not sure I understand the primary control piece. Yarn has always said, if you want so much memory and so much CPU, I will work with the operating system and give those resources to you. Is there more to the primary control piece than that, or? Yeah, so network. So network was one piece. There are two things that I didn't talk about here. I talked about GPUs, and Intel is actually working in the community to bring FPGAs with Yarn, right? There is stuff like GPUs and Yarn that we are looking at. Disk isolation, disk scheduling, as well as network isolation, network scheduling. These are very hard topics. I have a few backup slides as to why. Because in the shared big data cluster, you have several actors writing data on the disk and across the network. Think Spark applications hitting the local disk and doing remote I/O on data nodes. Yarn itself is doing a bunch of I/O. Things like HBase are serving their end users. So the I/O patterns of HBase it talks to HDFS underneath, and HDFS has its own I/O pattern, right? So there are a whole bunch of different actors who are sending, reading and writing and shuffling bytes on the disk as well as the network. So it's a very complex problem. We have taken some baby steps, but it's not there yet. So that's one piece. But our filter is still scheduling and isolation, right? There's a different point of view for networks, which is my operator has set up his own software SDN, right? Or I have my own firewall rules. And how do these apps run in such an environment? That's something we are not even looking at from the community point of view. So the second question was, once you start doing things like networks and resource monitoring, does it compete with other systems like Kubernetes and so on? There is definitely an overlap. We come from the data side. We continue to focus on data workloads. But the fundamental pieces on, if you go to a single machine, what a Yarn's node manager does is actually not a whole lot of different from what, say, a Docker daemon does or a Kubernetes kube engine does, right? So there's definitely a bit of overlap. A couple of years ago, from Hortonworks, we did some analysis of how Kubernetes and Yarn integrate. That fizzled out. It's coming back now. So the short answer is yes, there is overlap. How can I help you choose? I don't know the answer to the question. Yeah. You're not supposed to ask questions.
Your time is out? Is up.
We're out?
Yeah.
Okay.
Yeah,
thank you. So I know there are more questions. I'll be here out in the hallway. Please reach out to me. Thank you very much.